For over the last 2 years, this rocket has been the most powerful on the planet and is likely to remain so until the end of 2021 at the very least, in spite of what might be happening at Boca Chica, the Falcon Heavy. And although the engineering behind this mostly reusable rocket is nothing short of miraculous compared to what was possible a few years ago, this and also the subsequent rockets like the SLS and the Starship are all going to be operating under the same principle, chemical propulsion. And even when the Super Heavy and the Starship are finally in service, nothing essentially is going to have changed when it comes to the principles behind driving these ships. A chemical reaction that drives a reactive chemical out the nozzle in order to provide thrust. The same sort of thing that we were using back in the Apollo days and far before that. Now, in the course of making videos for this channel, I've talked about a wide variety of breakthrough or alternative forms of transportation or propulsion, including the Vasimir as depicted here, which has been worked on for quite some time, involving using electromagnetic waves to ionize a neutral type of fuel, and then driving those ions out the nozzle of the rocket at a very high rate of speed using electromagnetic force. The problem with this, of course, is the high amounts of energy involved, and it's been theorized, or at least concluded by most experts, that it's going to require fusion in order to make this practical, although this is being debated at the moment. Now, another form of drive that I have talked about on this channel, which is much more within the range of our current science and technology, is nuclear thermal propulsion, which involves using a nuclear reaction to drive hydrogen atoms out the nozzle of the rocket at a very high rate of speed, because hydrogen is the lightest element in the universe, and the faster that your propellant moves, the less of it you have to use in order to generate thrust, thus making it twice as efficient as a chemical rocket, allowing a spaceship using this type of propulsion to reach Mars in about 100 days. But it still involves the principle of using fuel, and as I've mentioned before, this propulsion has been around for a long time. The concept has existed since the 1970s. Now, something a little bit more high-tech is the Orion, although it's been around for a long time too, but it involves the rather brutal method of exploding small hydrogen bombs behind a spacecraft in order to provide thrust. Now, this ship would be a violation of a number of treaties, but it's about the most productive use of hydrogen bombs that I could possibly think of. But then again, something that's a little less dangerous is Project Daedalus, which has also been around for a very long time, which involves the use of fusion and deuterium fuel in order to provide an enormous amount of thrust, giving us the possibility of reaching the stars. But what if we could use a type of propulsion that doesn't use fuel at all and has no limitations as far as that is concerned? That would be simply miraculous. And what if this propulsion could put Mars within our grasp in as little as 3 days, give us access to the outer solar system or perhaps even the stars? And what also if this type of drive could protect us from one of the greatest threats that mankind could ever face? Get ready to be transported to the world of futuristic tech right now. Good evening, and welcome to part 2 of our double header here on the Angry Astronaut. As you can see, I've changed the lighting back because I'm interested to hear from you guys which type of lighting you like. The reason I went to low lighting before is because of the glare that it was giving to some of the posters back here. But in any event, obviously this way you can see me better, and I do have some other lighting that I'm working towards. But of course, starting this out as my new career, the funds are difficult to come by, but I'm not going to talk a lot about that right now. I'm just going to move forward. As those of you who've been watching my channel for a while know that I don't just deal with things that are happening now or developments like what's currently happening at Boca Chica. Perhaps by the time that this video comes out, the Starship will have taken its first hop. I certainly hope so. I've got my doubts, but maybe. Certainly hope that that's happened and that everything has been successful. But still, it's a long, long ways off before the Starship achieves orbit, let alone goes anywhere. And I like to look ahead, sometimes very far ahead when it comes to different types of propulsion, but not necessarily so far ahead to where it's difficult to comprehend. Even though a lot of folks believe that the warp drive, as it is often called, is possible, I don't tend to be one of those people who embrace it. I think that it may be possible sometime in the distant future, but certainly not in the next century. So I like to deal with next level propulsion that we know how to do now, at least in theory. And also, really, from a practical standpoint, it's not too far off. And in this case, I'd like to talk about photonic propulsion. And some of you folks may not know what it is, but it uses a lot of technology that we are very familiar with, but it is essentially propulsion that doesn't involve propellant at all. And so those of you folks who are familiar with this probably know that I'm talking about a light sail. But so far, the light sails that we've been experimenting with barely accelerate and certainly aren't very practical for something large. Could they be upscaled to something big like the Starship? Well, as a matter of fact, the answer is yes. Is that something that could be easy to implement? No, not at all, and not something for the very near future. But nevertheless, it could be. And could this type of propulsion get a ship, at least a ship of some kind, from Earth to Mars in 3 days? Yes, it could. And I'm going to explain how that's possible right now. Unlike many other types of next-generation propulsion systems, light sails have actually been successfully tested in space, and the first ones to do that was the Planetary Society with Light Sail 2. Contrary to popular belief, photons do have mass, although very, very little. It's their incredible speed that gives them their momentum and therefore their power that can be harnessed by a highly reflective material, and there's a variety of different types. And if you can deploy this material into a very large, very thin sail, then the photons can provide you with thrust. Now, although Light Sail 2 was successfully deployed, the amount of thrust that it's getting from the sun is minuscule, the weight of a couple of sheets of paper, and so therefore the acceleration is barely noticeable, and it's going to take many, many orbits of the Earth before Light Sail 2 is able to escape the influence of the Earth's gravity. Not exactly a high-speed propulsion method for getting to Mars. Now granted, the acceleration is constant and never stops because it isn't restricted by fuel, so eventually it's going to increase speed, but since the sun is 93 million miles away from the Earth, and Mars is even further than that, isn't that going to make this a very impractical way of traveling to Mars, especially where humans are concerned? Well, not if you bring the sun to the sail. And as ridiculous as that may sound, NASA thinks that it's possible. And the way that it would be implemented is having an extremely powerful laser directed at the solar sail to drive it at unbelievable speeds with 1g acceleration all the way to Mars, that is halfway to Mars, and then having a similar laser at Mars reduce the speed of the sail until it arrives with a 3-day total transition time. However, the mass of said spacecraft would only be about 100 kilograms, and this whole concept is not too dissimilar from the breakthrough Starshot concept, which is designed to explore the nearby star of Proxima Centauri. This project, founded by people like Stephen Hawking, proposes that we send a fleet of very small probes to Alpha Centauri using a phased laser array of up to 100 gigawatts worth of power. And this laser array would propel one probe after another up to a speed of between 15 to 20% that of light, which would allow it to reach the star within a couple of decades. However, this proposal has a number of problems, especially if we're talking about sending humans. First of all, the level of acceleration involved with this kind of system would kill any human crew almost instantly. Secondly, lasers passing out of the Earth's atmosphere would lose a lot of their power and accuracy, especially as the spacecraft traveled further and further away from the laser array. Also, you've got the Earth's rotation to deal with, and then finally, we're talking about very small probes here and very small light sails. Nothing along the lines that could carry, say, 100 humans to Mars. Is there a way to scale this up? Well, if you put the laser into orbit, where atmospherics don't have as much of an effect, that would certainly be a start. Putting the lasers between the Earth and the Moon would be an even better solution. Number one, because you could theoretically manufacture the lasers on the Moon and then deploy them without having to deal with Earth's gravity well, which would make things a lot easier. And secondly, you could deploy them to Lagrange Point 1, which is essentially a parking spot between the Earth and the Moon. This is an area where the gravitational forces of the Earth and the Moon cancel one another out, so anything you put here is pretty much going to stay put, which means that only on the rare occasion when the Earth gets in the way of your lasers are you going to have problems with striking the light sails with their power, thus making them more efficient. Another option would be to place the laser array on a near-Earth asteroid, or better yet, if you're in the mood to build a generation ship, hollow out the asteroid and use the light sail as the propulsion and the asteroid for the ship. That's if you're in the mood to get really science fiction. But how scalable is this? Well, it can get kind of ridiculous. The physicist Robert L. Forward proposed that a 75 million gigawatt laser array could propel a 78,500 ton ship just the speed of 50% of that of light, as long as it had a light sail 1,000 kilometers in diameter. A bit ridiculous and a bit huge for our purposes. So how do we go about making a Photon Starship? Well, first of all, this is highly unlikely given the fact that we're planning on using the Starship fairly soon, and this kind of propulsion is a long ways off, but let's say we could. First of all, you'd have to get the Starship into orbit using conventional chemical rockets. There's no way around that. No form of propulsion that we're familiar with is going to be able to escape Earth's gravity without chemical rockets. But once the Super Heavy is detached, then things start to change a bit. Instead of rendezvousing with a tanker, the Starship rendezvous with something like this. A large solar sail made of a variety of different types of materials or alloys. preferably nanotubes of some kind, although of course developing these, especially on this scale, is something beyond our current technology. However, something that's certainly going to be possible, especially in zero-G in the near future. Big as it is, the Starship would only occupy that little area at the center of the sail, because the sail itself would have to be at least 1 kilometer in diameter and probably larger, depending on the materials involved. The better the materials, the smaller the sail could be. Now, this might sound impossibly huge, but keep in mind that these materials would only be a few nanometers thick, and so could be furled up into a relatively small area when deployed in the first place. Once deployed, the light sail receives a blast of laser energy from the laser array at Lagrange point 1 preferably, and is sent on its way at a very high rate of acceleration, perhaps as much as 1 g. If they could manage that, they would reach Mars within the space of 3 days. But if we wanted to be a little bit more realistic about it, at least for a mass as large as the Starship, you might be talking more along the lines of a couple of weeks. Still, a massive improvement over 6 months. Now, a 2 to 3 week transition time would have all kinds of advantages besides just limited exposure to cosmic rays and microgravity. If you wanted to build a colony, you wouldn't have to wait for Earth and Mars to be in conjunction with one another. You'd have a much larger launch window, allowing your ships to make perhaps multiple round trips, thus dropping off not 100 passengers in one go, but several hundred. And it wouldn't just be passengers either. You could also drop off hundreds of tons of cargo using this method, and you would have more than one launch window. You could also take advantage of when the planets were in opposition, the diagram on the left, as I've mentioned before, making a stop off by Venus on the way. Also, you'd be closer to the Sun, picking up more photons in the process and more free energy as you were making your trip. This system could have a lot of practical applications besides just transportation. Remember how I said you could send 100 kilograms in 3 days using this system? Well, let's say that there was some sort of vitally needed medical supplies or some sort of crucial technology required, and you needed to get it between the two planets in a short amount of time. This is the only realistic way to accomplish that. But how do you build these laser arrays without a bunch of nuclear reactors that you hope don't blow up on the pad? Well, in another one of my episodes, I talked about a space-based solar collector, which would be about the size of 9 football fields and would be able to generate 5 gigawatts worth of power. So 10 of these would be sufficient for the 50 gigawatts required for the laser array. Granted, this is something that would take a while to build, but with the transportation and hauling capacity of the Starship, it's definitely not impossible. And ships with photon drives could also reach the outer solar system, assuming of course that we sent a laser array ahead of time to a place like Saturn to slow the ship down, or if the ship made use of a particularly ingenious type of reflective technology, which I'm not going to try to explain here, but you can find linked in the description if you're interested. Regardless of what kind of technology you had to use though, it would be very difficult to go back, unless of course you had a laser array at Saturn, but without that, you would have to be resigned to the fact that you were there to stay. But I mean, it's all well and good that we have fast transportation throughout the solar system, but realistically, who's gonna buy into this? Well, what if buying into it meant saving the human species? And I'm not exaggerating here. A laser array that could power a solar sail could also stop an civilization-killing asteroid. Our civilization is living on borrowed time, And although recent impacts have been relatively small, and that is to say about thermonuclear explosion size small, it's only a matter of time before something very big and something very serious is heading our way. And then what do we do about it? Well, believe it or not, the very same technology that could power a light sail and also provide power to our planet could save it from an incoming asteroid. The same photons that are capable of pushing a craft to near relativistic speed are also capable of deflecting an asteroid off its path and saving our civilization from certain destruction. So not only can this give us the ability to explore the stars in our solar system, it can ensure that we survive long enough to do so. Do you know what makes me both excited and also really pissed off about next generation types of propulsion? It's not the fact that there are so many obstacles in our way in terms of technology or science or engineering. Everything that I've talked about in this particular episode, it's daunting, no question, and some of the technology involved is going to, require some advancement, but we could certainly do it, I would say, within the next century. But are we actually going to do it? I really, really doubt it. It's taken us half a century to go back to the moon, and that's with using conventional chemical propulsion, something that the medieval Chinese had perfected 1,000 years ago. I mean, it's absurd. We really need to be exploring other types of propulsion far more aggressively than we actually are. But we're not, because those in power and those who have the resources to do something about it, they don't see the value in it. Now, nuclear thermal propulsion, that might be something different. I may talk about that again. I've talked about it in past episodes, but since we're going to be test firing a nuclear thermal engine in 2024, maybe that's something that may blossom sometime here before I die, although I've got my doubts. But the problem is there is just no sense of urgency to exploring not only the inner solar system, but also technologies that would allow us to explore the outer solar system as well. And it's absolutely vital that we do this, that we expand our civilization to as many locations as possible, not just to ensure our long-term survival, but also simply for the sheer joy and the benefit of learning new things, exploring new places, perhaps discovering new forms of life, none of which is going to be possible until we embrace new types of propulsion technology. And these light sails, these massive light sails and immensely powerful lasers that I talked about, well, they're doable, but I don't see them happening anytime in the near future. In any event, I hope I'm wrong. I really do. But in the meantime, continue to support this channel if you like both the futuristic and the more conventional aspects of it. I wanted to kind of give you a quick taste of both now that this is my full-time profession, and continue to support this channel because, as I mentioned in the last episode, YouTube is entirely too fickle for me to do it with that. So until that time comes and I'm fully self-sustaining and we are starting to explore the cosmos with a greater sense of urgency than we're doing now, I urge all of you to stay angry about space.